Hi everyone. Welcome to pre-lab lecture for experiment 6B, preparation of Pava solution and determination of the pH of Pava solution. I would like to just real quick go through the concept of Pava, dividing the Pava, which I know you have covered in the lecture. I will share my screen here, probably maybe just go through the um, definition of a power. Here is the definition of a power. Power solution is a solution that receives a change in pH. A solution that receives a change in pH. It consists of a weak acid and a weak base or its conjugate base. It's important to note that a power solution is prepared by using weak acid and its conjugate base. General or generic chemical, all right, general formula for, all right, general formula for weak acid, all right. This is a weak acid in equilibrium, or not really in equilibrium, but doesn't want to go to the acid, the product side. So it's not in dynamic equilibrium, just like that. With its conjugate base and conjugate acid, we may have this exists as hydronium ion because it doesn't want to exist in H2O. This is a weak acid, all right. Here is the acid, and here is the base. How do we know that this is an acid, this is a base? Please recall from Chem 1 how to determine the conjugate base given the acid is by removing, all right, removing hydrogen ion from a species, you end up with the conjugate base. Recall the conjugate acid base pair. So for a weak acid, all right, such as acetic acid, all right, such as acetic acid, CH3, COO. This is what we call the acetic hydrogen. All right, this is acetic hydrogen, and this right here, if we remove the acetic hydrogen, we end up with the, this is C here, and to say C O negative. What I've done here is I've generated, or I do have conjugate. This is conjugate acid. This is the conjugate what? Conjugate base. Conjugate acid base pair. When one prepares an acid, pick two substances which is conjugate acid base pair. And if you make equal concentration of, let's say, acetic acid and conjugate base, you end up with what we call the a Pava solution. A Pava solution. All right. You will never see a Pava solution prepared using strong acid. Generally, Pava solution are prepared by using an acid with its conjugate base. How do you know that you are dealing with a weak acid when you are given a, Ka or pKa of an acid? No, that's a weak acid. Now, the question is, how do you know, or which criteria is used in determining which weak acid is uh, used in preparing a powder solution which receives pH within a specific pH or within a given pH. For example, let's say pH of 5. How will I determine which acid-base pair will I use to prepare a powder solution which will receive pH around 5? The key thing is knowing the pKa value of the weak acid given the Ka, all right? You can find the pKa, or given the pKa, you can take it from there simply because of Anderson-Hasselbalch equation, all right? Remember from Anderson-Hasselbalch equation, pH equals to pKa plus log of what? Log of the conjugate. Let me just put here conjugate paste over what? Over acid, conjugate acid. So here, if you look at the, I do have here the conjugate acid, all right? The conjugate acid for, I do have here conjugate acid. I meant to say this is the conjugate acid right here, all right? Conjugate, what? Conjugate um, acid. So now, what's happening here is if you are to make a powder solution which receives pH around pH 5, you will pick an acid whose pKa, is closer to 5. If pKa is, let's say, if I have a Ka or pKa of, let's say, pKa of 10 point 5, all right, 0, and another acid with 4.7 6 like that, I will pick a pKa. I will pick an acid whose pKa is uh, closer to the desired pH range we want to. That's the criteria by which you select the weak acid you need to prepare your solution. This is the concept you're going to use in completing the data sheet. Of course, you know the Anderson-Hasselbalch equation, conjugate acid, conjugate base, or in other words, the concentration. This can also be the concentration. All right, this is the concentration of the conjugate base, conjugate acid, which is of course concentration is molarity. From this is uh, molarity. It's just shown with uppercase M, molarity. So you should have the molarity of the acid, molarity of the base at the top. And the equation you see here is Anderson-Hasselbalch equation we have seen before. I don't want to go further than this. Let me just go to the data sheet and show you what you need to do for part one and part two. There are two parts. Part one is preparation of powder solution, and part B or part two is calculation of the pH using Anderson-Hasselbalch equation. I'm going to clear the screen here, clear everything. I'm gonna close here, and on the, all right, uh, I do have the data sheet here. This is the data sheet, and in part one, let's see. Part one is, part one right here is preparation of, all right, preparation of powder solution. The active link here is not active. I do have the simulation on, I do have the simulation on Canvas. look at the direction. You have to prepare a power solution. And remember what I said, all right? Remember what I said in terms of picking the weak acid. You need to pick a weak acid whose desired pH, all right? I mean, whose pKa is closer to the desired pH value. I've pre-selected the pH value you should be working with, all right? I've selected the pH value you should be working with. Forget about what is highlighted on the simulation. For example, in part one, let me just clear this real quick. In part one, the desired pH is what? Is the desired pH is 3.8, all right? This is the targeted pH. Power 2 is targeted pH is 6.10. Power 3, the targeted pH is 9.9.70. And I think there is power 4 here. Last one, power 4, targeted pH is 10.50. What is the targeted pH? Targeted pH is the pH you want to, or you want to adjust the concentration of the weak acid, concentration of the weak base, all right, so that you know, when you plug in Anderson-Hasselbalch equation, it will give you this pH. I will load the simulation. I load the simulation, and you'll see how to do that on part. This is for part A. All right. Ignore the you see the red arrow here is for targeted pH. Forget about the this arrow here. This is the targeted. All right. Already I do have the targeted. This is targeted. So if we were to prepare, for example, right? If we were to prepare a power solution, all right, a power solution whose all right, whose pH we are targeting is 6.6. We cannot use maybe pH of what? We cannot use pH of, or we cannot use this acid right here because the pKa is way off 9.66. We need to pick an acid base pair here, which, all right, which has a pKa value, or whose pKa value is closer to 9.6. I think this is what we need: ammonium chloride and what? And uh, ammonia. This is the base, this is the acid, right? You should be able to see which one is the acid, which one is the base. So with that, if this is the targeted pH, you'll have to move around this until, all right, until you have 9.6, 9.6. It doesn't get there. Maybe I need to move this one, and you can use this to move around until I end up with 9 point what, 9.6. Maybe this, maybe that. Yeah, that is what it is. So if I look at the acid, this will be now pH right here. Uh, this is the what? This is the base, and this is the what? This is the acid. So if I want to write the Anderson-Hasselbalch equation, pH, and remember the targeted pH here was 9.66. The red arrow pointed 9.66. But in the data sheet, I have already highlighted what are the targeted pH. Yours is to adjust or change the concentration of the acid concentration of the base by picking in one of these using the criteria I just pointed out. How do I select the acid base pair? in preparation of the PAVA. So here is pH equals to pKa, all right, plus log of what? Log of, in this case, you write the concentration, which is um, the base is 0.84, all right, 84 of 0.03. This is Anderson-Hasselbalch equation, and pKa is 9 point what? This is 9.2 5. This is Anderson-Hasselbalch equation. So I may just get rid of this and have the pKa value and put everything. This is Anderson-Hasselbalch equation. I will need, if this was pre selected pH for my case. So in that case, that is what you will do for part A. For part A. So if I cancel this and show you this, this is the targeted pH which you need to work with. Targeted pH for 3 point what? We have 3.8, 6.1. So you need to identify the acid, you need to identify the conjugate base, you need to write the concentration of each one of them, all right? And then as Anderson-Hasselbalch equation, you're gonna write it down here, all right? Or you will have to take a picture of it, all right? Conjugate acid-base pair. So remember, the arrow, you don't need the arrow here. The arrow already I've selected for you 3.80. That stands for the arrow, it's shown in red. And then you'll adjust the concentration of each one of them, all right? You'll adjust the concentration of each one of them. Please read the direction here, all right? You record your finding, use Anderson-Hasselbalch equation information that you recorded to justify the pH value. You need to show, all right? You need to show your work. Please show your work right here. Show your calculation on how you end up with this value. You need to do that for PAVA 1, PAVA 2, all right? And all the way to PAVA 4. That is part what? That is part 1, all right? And then in part 2 is more or less the same, all right? In this case, you'll have to determine the pH. Part P, you will determine the pH, and it has a different simulation on Canvas, all right? You have to have a different simulation for this measuring the pH of PAVA solution. The simulation will show the pH. So in this case, you will see the pH of PAVA solution. 6 of them, base pair, and the concentration of the acid and base can be adjusted over the magnet. Use this simulation. This is where you'll have to do what? You'll have to take a picture and you'll have to upload or paste it on your document. You'll use an acid-base pair. Remember the criteria by which you select the acid-base pair and adjust the concentration. You are given the pKa. So here is the simulation. I'm just going to show you. This is for part A. For part P, look at this pH value. This is what you need for part P. You are given the pH value. So pKa, you have to have 6 of them. 1, 2, 3, 4, 5, 6. So if I have that, pH equals to 9. Look at the pH, 9.28. But in the direction you are given the concentration, let's see. I'm going to work on the first one. Let's look at the first one on part P or part 2. So if a power solution is made by mixing this and that, so I need the conjugate acid concentration should be adjusted to 0.78 and this should be adjusted to 0.54 molar. This is the conjugate base of this weak acid. What is the expected pH value? All right, that is when you see, and then here, what is the simulated? Take a picture. In this case, you need to look at the pKa for this acid base pair. Let's see this. This is the pKa right here. Let's see here. This is what it is. The pKa, this is pKa. So you know the pKa right here. The concentration is given for the acid. This is the concentration of the acid. This is the concentration of the base. And then what calculated, you have to calculate. If you know the pKa, you know the concentration of it, you need to calculate. And then you do what? You do the simulation, 0.78, 0.78 and 0.75. So let's adjust this to 0.54. I'm going to adjust that to 0.54. That is 5253. And then I'm going to adjust this to 74. So let's adjust this to 74. 73. So this is the concentration of what? This is the concentration of the acid. This is the concentration of the conjugate base. What is the pH? This is not the pH. And then you will write, you know, the pH. You write the pH. You write the pH. What is the simulated pH? The simulated pH is not that. The simulated pH is given, simulated pH is given, what is the simulated pH? 9.27, right here, 9.27, that is simulated pH. And then what? Next is, we want, all right, we want to identify the acid, identify the base, and what you will do is uh, you will you'll have to include the acid base pair here to make sure that make sure you have make sure you know the acid base pair for all the six. Do the calculation, take a picture, and attach to your calculation. You need to adjust to your calculation the Anderson-Hasselbalch equation for part 2. This is part 2. So what you need to do is adjust the pH, and there you go. You'll submit the assignment via Canvas on the respective folder. Other than that, that's what I wanted to go over before you embark on completing the data for experiment number 6B. Thank you. Stop sharing the screen. See you in class next time.